Hello everyone, welcome to Extra Marks. So let's discuss the topic data handling. Today under the chapter of data handling, we are going to discuss about organization of data. Under organizing data, we will learn about ungrouped and grouped frequency distribution table. After that, we will see what is a histogram. Then we will finally summarize all the topics. So let's start with the very first topic, that is ungrouped frequency distribution table. So let's understand how do we make frequency distribution table. Let's take an example over it. Suppose I have a group of 30 students were asked for their favorite star. That means I asked for their favorite star to whom? To the group of 30 students. Now the results are, these are the results. So these are the favorite star of 30 students. Like the first students liked Abhishek Bachchan. Second student's favorite star is Hrithik Roshan. Third student favorite star is Shah Rukh Khan. Fourth student favorite star is again Shah Rukh Khan. Fifth student favorite star is Amir Khan, and so on. 30th student favorite star is again Shah Rukh Khan. Now, this is the data in the raw form. Let's arrange the data. Let's organize the data. So for this, I will make a frequency distribution table. So in that frequency distribution table, I am taking 3 columns. One column is of favorite star. Second column is of tally mark, which will show you the frequency. And the third column is of number of students. So in the first column, I have written the name of favorite star, which are Abhishek Bachchan, Shah Rukh Khan, Amir Khan, Salman Khan and Hrithik Roshan. Only these 5 stars are mentioned in this list, right? After that, now from this raw data, you have to count how many students like Abhishek Bachchan. So from here, I can count that 1, then where is the next one? Yes, so this is the second one, and where is the next one? Yeah, this is the third one. So 3 students, overall 3 students' favorite star is Abhishek Bachchan. So what I'll write over here in column of number of students 3, and in the column of tally mark, I will show 3 tally mark over here, 3 vertical mark like this, okay. Now the second star is Shah Rukh Khan over here. So let's count how many students like Shah Rukh Khan. So let's count it. It is 1, then 2, after that 3, then 4, then 5, then we have 6th one, then we have 7, 8, and the last one is 9. So overall 9 students like Shah Rukh Khan. After that, similarly, for Amir Khan, we have 7 students. For Salman Khan, we have 5 students. And for Hrithik Roshan, we have 6 students. Now, both are same data only, but the above data is in raw form and the below data is in organized form. We can easily read this data. We can easily handle this data. We can easily extract the information from it. Just by looking at this table, I can easily find over here that how many students like Abhishek Bachchan, or how many students like Shah Rukh Khan, or which star is least liked, which star is most liked. Just by looking at this table, I can answer all these questions. But if I look at this data, this raw form of data, it is very complicated to handle this data, or it is very complicated to extract the information from it, right? So, this method for representing the data, we have converted the raw data in this form. So, this method for representing raw data gives you the correct information of data without any complications of reading the data. And in this table, the number of tallies for each star is giving you the number of students who like that particular star. So overall, what it is basically the frequency of star. Like 9 students like Shah Rukh Khan. So what is the frequency of Shah Rukh Khan among 30 students? It is 9. Similarly, 6 students like Hrithik Roshan. So what is the frequency of Hrithik Roshan among 30 students? It is 6, right? So the number of tally mark over here is representing the frequency of star. So now from this table, I can easily extract the information. I can easily conclude the information. That is, Shah Rukh Khan is liked most among students. That is 9 out of 30 students like him. Right? So here you can see that maximum number in this table. Maximum number is in front of Shah Rukh Khan. So here I can see that Shah Rukh Khan is liked most among the students. 9 out of 30 students like Shah Rukh Khan. Similarly over here, Abhishek Bachchan is liked least among the students. Abhishek Bachchan is liked least among these students because from this table, you can easily see that in front of Abhishek Bachchan, only we have 3 students. That means only 3 students like Abhishek Bachchan. So, he is the least liked star among these students. And Amir Khan, Salman Khan and Hrithik Roshan, these are liked by 7, 5 and 6 students respectively. So overall, what I want to conclude over here is that from this particular table, from this particular frequency distribution table which you have drawn over here for the raw data given, now you can easily extract the information, you can easily conclude the information from the data. So that is the advantage of organizing the data. That is the advantage of organizing the data. And in organizing the data, we have learned frequency distribution table, how to construct frequency distribution table. So this frequency distribution table is nothing but ungrouped frequency distribution table because I have not grouped the data. I have written every data individually over here. So therefore it is ungrouped frequency distribution table. Now let's take a question. So here the question is, in the given frequency table, the number of students whose favorite activity is games is. So see, for dance, how many students like dance or how many students' favorite activity is dance? It is 3. It is 3. How many students like games? It is 5. This one is 5 plus 1, 6. How many students like music? It is 2. And how many students like computers? It is 4. And what was the question? Whose favorite activity is games? We have to find the number of students whose favorite activity is games. So obviously the answer will be 6 for this question. What is the answer? 6. So basically you need to know how to count the tally mark. That's it. Now, let's see grouping of data. How we are going to group the data and what is the need or what is the requirement of grouping the data. See, sometimes the raw data given to us is very complicated to handle and it is very lengthy, right? So at this moment, it is not very helpful to represent data just by using tally mark and frequency table, right? When your data is very lengthy and very complicated, it is not suggested or it is not advisable to represent your data just by using tally mark and frequency table, as there might be several entries for a particular value in data. For a particular value, you can have several entries. In that case, what you can do, you can consider those several values as a single value. You can group those you can group all those values and you can consider as single value. That is the meaning of grouping of data. I repeat, what you can have in the raw data, you can have several entries for a particular value in data. So beside that, there might be some entries which are close enough to each other and we can consider it as single value or as the same value, right? And this is known as grouping of data. So to avoid such problems and to save our time, we usually group the data. We usually group the data in some data ranges. In some data ranges, that is like 0 to 10 or 10 to 20, 20 to 30 and so on. I'll make some range over here, okay? So in some data ranges, I'll group my data and all the values lying in that range will be considered as one value. All the values are lying in that range will be considered as one value. So when you have several entries for a particular data or for a particular value, we go for grouping of data. We go for grouping of data. And how do we group? According to the entries given. Obviously, it depends upon the data given. After grouping the data, all the values lying in that range will be considered as one value. Now, I'll explain you all these points again with the help of an example. So, let's take the example. Suppose I have the ages of people who participated in a recent survey. What kind of data I have? I have the ages of people. I have the ages of people who participated in a recent survey. So the age of first person is 6 years. Age of second person is 20 years. Age of third person is 25 years. Age of fourth person is 21 years. Then 34 years, 22 years, then 31 years and so on. So you can see that this data is very lengthy. This data is very lengthy. So what I'll do, I'll group this data. I'll make the range of ages. I'll make the range or the group of ages over here. And after that, I will construct the frequency distribution table. That is, I'll make the age group, 0 to 10 year age group, then 10 to 20 years age group, 20 to 30 years age group. Now after that, after making those age group, right? Now, whichever person is lying in that age group, like 0 to 10 age group, I will count that age in that group only. That is the meaning of grouping of data. Let's do it. So here, I have made the age group of 5 to 15, then 15 to 25, 25 to 35, 35 to 45, 45 to 55 and 55 to 65. Why I have not considered the age group between 0 to 5? As there is no people in this age group in this particular data. There is no people over here of 1 year, of 2 year or 3 year or 4 year, right? So that's why I have not considered this age group, right? So I started making the age group from 5 years. So it is first 5 to 15, then 15 to 25, 25 to 35, 35 to 45, 45 to 55 and 55 to 65. What is the range over here? What is the range of my group over here? How to find the range? Range is nothing but upper limit minus lower limit. That is 15 minus 5, which is 10, or 25 minus 15, which is again 10, 35 minus 25, 45 minus 35. You have to subtract upper limit with the lower class limit. So you will get the range of your grouped data, right? So this is the range, that is 10. So I have taken the range of 10 for grouping this age, 5 to 15, 15 to 25, 25 to 35 and so on. Now let's count how many people are lying in this age group or are falling in this age group 5 to 15 years. Let's count it. So in 5 to 15 years, obviously 6 will lie in this age group 5 to 15 years. So 1. After that, which one is there? Yes, 9. I got the second one. 9 is falling in this age group. So next is, yes, now I am getting one person whose age is 15 years. Now the question arises, this person of age 15 years, I should count him or her in the first age group or the second age group, because 15 is lying here also and here also. 15 is lying in 5 to 15 age group also, and 15 is lying in 15 to 25 age group also. So whenever you are getting the boundary values, that is upper class limit or lower class limit, always we consider that value in the group whose lower class limit is matching with that value. That means 15 is the lower class limit of 15 to 25 age group. So I will count this person in this age group 15 to 25, not in 5 to 15, right? So what is the rule over here? Whenever you are getting such values, which is the boundary value or the upper class limit or lower class limit value, in that case we consider that value in the group which are lying or which are matching with the lower class limit, right? So here I'll not count this 15 in this first age group. Okay, so I'm not circling that value. After that, 12 will lie in 5 to 15 age group. Then after that, 11 will lie. After that, let's count. So not 16, not 27, not 28, not 15 again. After that, not 16. Yes, 14 will lie in the age group 5 to 15 years. 14 will lie. Then let's count. Yes, then 10 will lie. Okay, so here 1, 2, 3, 4, 5, 6. So there are total 6 people who are lying in the age group 5 to 15 years, right? After that, let's count how many people are there who are lying in the age group 15 to 25 years. Now, I will count this particular 15 in this age group. So, let's count now. Let me change the color of my pen. So, here 20. So, 20 will lie in the second age group 15 to 25. After that, we have 25. Again, I'll not count 25 in this age group 15 to 25 because it is not matching with the lower class limit. I will count it in the age group 25 to 35, right? So, 25 I'll not count. Then I'll count 21. I will count 21. Then I'll count 22. Then I will count not 55, not 32, not 40, not 48. Then which one will come? Not 28, not 29. Yes, now 24 will come. Now the next is 24. After that, what is the next number which I can consider in the age group 15 to 25? So not 28. Yes, I can consider 23. After that, I can consider 16. After that, I can consider 17. Then I can consider 22. Then I can consider 21. Then I can consider 20. Now let's count. 1, 2, 3. After that, 4. Then 5. Then 6, 1 second, 1, 2, 3, then in the second row we have 4, then 5, 6, 7, 8, 9, 10, but we should have 13. I think we are missing this 16, right? We are missing 2 more. Yes, no, we are missing 15. Yes, we are missing this 15. That will lie in the second age group. And we are missing 1 more, I think. Let's check it out again. 43, 14, 29, 28, 48, 61, 27, 17, 52, 62, 47, 63. No, not 29, not 21, not 34, then not 10, 43, 32, 20 and 40. Now let's count again. So it's 1, 2, 3. After that 4. Then we have 5, 6, 7, 8, 9, 10, 11, 12. So I think we are missing one. Let me check again. We have to consider those values which are lying in the age group 15 to 25, right? So not 47. Oh yes. We are missing this 15. We are missing this 15 because it is matching with this lower limit. So obviously we are missing this 15. Now the total count is 13. So similarly, you can find that how many people are there who are lying in the age group 25 to 35. After counting, you'll get it as 18. How many people are there who are lying in the age group 35 to 45? So it is 17. How many people are there who are lying in the age group 45 to 55? So it is 14. And how many people are there who are lying in the age group 55 to 65? So it is 9. So what you can conclude over here from the two data, both data are same. It is in the raw form and it is in the organized form. If I'll give you this data, obviously you can easily conclude the information from it. You can easily find how many people are there who are lying in this age group or who are lying in this 55 to 65 year age group. Rather than counting like this, it is taking time, right? It is time consuming. So obviously the data in the organized form is always easy to handle and we can easily extract the information from it. And that's why we always organize the data, whether it is in the form of grouped frequency distribution table or ungrouped frequency distribution table. This one is what kind of table? It is grouped frequency distribution table. This one is grouped frequency distribution table because we have grouped the ages over here. So that's why it is the grouped frequency distribution table. When we don't grouped our observation, then such kind of table is called as ungrouped frequency distribution table. That is the only difference. Now, let's see what is histogram. You people have already learned about bar graph. It is similar to that only. So, histogram is a special type of bar graph. It is a special type of bar graph. What kind of special is there? The difference between the bar graph and the histogram is that histogram is used to represent the grouped frequency distribution table graphically. Just now you people have learned about grouped frequency distribution table by that ages example, right? If you want to represent that grouped frequency distribution table graphically, we use histogram. So histogram is a way to represent the grouped frequency distribution table graphically. And in histogram, there is no space between the bars. Like in bar graph, we used to have space between the bars like this. We used to have space between the bars like this in bar graph. But in histogram, this space is not there. All are adjacent to each other like this. There is no space. Why there is no space? Because your data is grouped. Like suppose you have 0 to 10, frequency 5. Let's say 10 to 20, your frequency is 2. 20 to 30, frequency is again 5. So as the data is grouped, that's why you don't have any space between them. Don't worry, I'll give you one fresh example based on histogram. So now let's take an example over here. So what is the example over here? One histogram is given and based on this histogram you have to answer some questions. So let's see what kind of data given over here. So here on y-axis we have number of people and on x-axis we have the ages of those people, right? So again I have taken the example of ages only, right? So here you can see that between 0 to 5 there is no people. That means in this age group 0 to 5 years there is no people. That's why I have shown this range with the help of distorted line. This distorted line tells you that in this range there is no particular value, right? So that means in this age group 0 to 5 there is no people. Now in the age group 5 to 15 years, how many people are there? 5 people are there. In the age group 15 to 25, how many people are there? 13 people are there. Then 25 to 35, 18 people. 35 to 45, 17 people. 45 to 55, 14 people. And 55 to 65, 9 people are there. Now, what we have to answer over here, how many people have age 45 years or more? How many people have age 45 years or more but less than 55 years? So 45 years or more but less than 55 years means they are talking about the range 45 to 55. How many people are there in the age group 45 to 55? 14 people. So just by looking at this histogram, you can easily answer this question. Now what is the next question? The next question is, how many people have age less than 25 years? How many people have age less than 25 years? It is 13 plus 5, that is 18. So see how easily you can extract the information when the data is given in the form of histogram or in the form of frequency distribution table. That is the advantage of organizing the raw data. Now, let's discuss one last example. The example is Uncle John owns a garden with 30 apple trees. In his garden, how many apple trees are there? 30 apple trees. Those 30 apple trees have different height in inches. And the height of those 30 apple trees are given over here. What we have to do? We have to make a grouped frequency distribution table for this data, and after that we have to make a corresponding histogram for it. So first, let's make the grouped frequency distribution table. So in order to make this table, you can have 2 or 3 column, okay? That is the third column for tally mark. If you're interested in putting the tally mark, you can also put that. So third column is for tally mark. So height of tree is 60 to 70, 70 to 80, 80 to 90. What I have done, I have made the group of height 60 to 70 inches. That is, I will count those trees over here which are lying in this height range. Then after that, I'll count the tree in this height range 70 to 80 inches. Then 80 to 90 inches. Okay, so this I have grouped the height of tree. Now you have to count that how many trees are there who are lying in this height group, that is 60 to 70 inches. So here you can count in this data, and after that you will get the frequency 6 after counting. After that, count how many trees are there which are lying in the height group 70 to 80 inches. So it is 17 trees. And how many trees are there in this height group 80 to 90 inches? It is 7 inches. Now here I have made the grouped frequency distribution table for this particular data. Now based on this grouped frequency distribution table, you can easily construct your histogram. Let's construct it. So this was my table, grouped frequency distribution table. So I can easily see that from 0 to 60, there are no trees whose height are in between 0 to 60 inches. So that's why I will represent this 0 to 60 with the help of distorted line or jagged line, which will represent that in this range there is no data. After that, you have 60 to 70 inches, 70 to 80 inches and 80 to 90 inches. Now in 60 to 70 inches, how many trees are there? 6 trees are there. In 70 to 80 inches, 17 trees are there. In 80 to 90 inches, 7 trees are there. So this is how you can easily construct your histogram based on this grouped frequency distribution table. Now let's summarize all the points. This you have to, this is your homework part. You have to tell me that this figure is showing what kind of graph. Okay, this is a graphical representation of a data. I'm giving you the options also. Please quickly take the screenshot. After that, we will summarize. So simply a graphical representation of data is given over here. You have to tell that what kind of graphical representation it is. Your options are, first is histogram, second is double bar graph, third is pictograph, and fourth one is bar graph. So I hope everybody has taken the screenshot so you can answer this question easily. We have studied all kind of graphical representation. Now let's summarize all the points which we have discussed today. So first, we have learned organization of data, right? Organizing and grouping of data. So handling raw data, you know that it is very complicated, and to extract the information from it is also very complicated. That's why we always try to organize the data either in the form of grouped frequency distribution table or in the form of ungrouped frequency distribution table, right? So we have two types of frequency distribution table, grouped and ungrouped. So that's all from my end. I hope everyone enjoyed my lecture. Thank you so much for joining. Keep learning.